Hi guys, it's Mrs. Williams. Today we're going to look at solving systems of equations, and there's at least 3 different ways that we can do that, and we're going to look at 3 ways today. The first method is substitution. Now, if you remember the substitution method, the idea is to solve one of the equations for one of the variables. Doesn't matter which one. For instance, here's a system 4x minus y equals 9 and y equals 12 minus 2x. The second equation already is solved for y. So if I know that y is 12 minus 2x, I can take that and substitute it for y in the other equation. And then I'll only have one variable left. Because what happens is I'll have 4x minus, now instead of writing y, I'm going to write 12 minus 2x, and then the rest of the equation equals 9. Now I have one equation with one variable, and I know how to solve that. So I'm going to distribute my negative. Then we combine like terms, so we have 4x plus 2x. That's going to give us 6x minus 12 equals 9. We're going to add the 12 to both sides of the equation so we can isolate the x. We have 6x equals 21. Now to get x by itself, we divide both sides by 6. And x equals 21 over 6 can be simplified. That can be simplified to 7/2. And in all honesty, I don't care if you change it to the decimal even. That would be x equals 3.5. Either one of those is okay, whether it's 7/2 or 3/5. But we're not done with our problem because we only solved for one variable. You now have to find y. You get to pick which equation do you want to use. You can use 4x minus y equals 9, or you can use y equals 12 minus 2x. I'm going to pick the second equation because since I'm looking for y, it makes sense to use the equation that's already in y equals form. So y equals 12 minus 2. Now I also find, I used to be a decimal person when I was your age, but I've learned that fractions are actually easier because if I write the fraction in there, I see, oh, look at that. The 2's cancel and it's just 12 minus 7. And now my y is 12 minus 7, which is 5. The one last thing we need to do is write our solution in the correct way. Our solution is an x value of 7/2 and a y value of 5. It's an ordered pair. That means parentheses because it's an x and a y value and they're for different variables. So 7/2, comma 5, and that is our solution. Because we know if we would graph that on an xy plane, we'd go over 3.5 and we go up 5 to find our solution point. Okay, guys, that's the first method. Next, whoops. Okay, so our next method is simultaneously, or sometimes, and I usually prefer, the elimination method. Now, in the elimination method, the idea is to eliminate one of the variables by adding the two equations together. Now, if we look at these two equations, 5x minus y equals 16 and 2x plus 3y equals 3, and we try to add them together, we're not going to eliminate a variable because we're going to have 7x's and 2 y's. However, if I decide, and I get to pick which variable it is I want to eliminate, if I decide I want to eliminate the y's, I'm picking that because I have a positive and a negative y, I can multiply the top equation by 3. If I multiply the top equation by 3, that's 15x minus 3y equals 48. And I'm leaving the bottom equation alone. 2x plus 3y equals 3. Now, why did I do that? If you look at these equations now, the coefficients on the y's are the same except for the signs. And that means when I combine the like terms, they're going to cancel. This is almost, now figuring out how to do this and what to multiply by, it's almost like finding a least common denominator. You want to find that coefficient that you need to multiply the top equation by or the bottom equation or sometimes both equations by, so that the variable you want to eliminate has the same coefficient, but you also want to make sure one of them is positive and one of them is negative. Okay? So we add now, 15x plus 2x is 17x. When we add the y's, they're going to go away to 0. And 48 plus 3 is 51. Now to solve, we divide both sides by 17. And 17 goes into 51 3 times. We now have our x value. Now, just like in the previous method, we get to pick, because we're not done. Pick which equation you want to use to find the y value. You can pick the first equation, 5x minus y equals 16, and pick it before you multiplied by the 3. Or the 2x plus 3y equals 3. I'm going to choose 5x minus y equals 16. And if I let x be 3, that's going to be 5 times 3 minus y equals 16. So 15 minus y equals 16. And if I subtract the 15 from both sides, I get negative y equals 1, which means that a positive y is negative 1. Last step, write our solution in the correct form. It's going to be the ordered pair, 3, negative 1. And it has to be in the correct order. Remember, it's an x value, a y value, always in that order. Okay? All right. 2 methods down, 1 left to go. The last method is graphically. So the graphing method, you graph both lines, and where do we find the solution? We find the solution at the point of intersection. So let's see. Let's take the top equation, 2x minus y equals 4. Now there's several ways you can go about graphing this. I think a lot of you on this equation would rewrite it in the form 2x minus 4, right? You would put it in your slope-intercept form. And that would mean that your slope is 2 and your y-intercept is negative 4. It's okay if you don't. You might want to instead say, okay, I know that my y-intercept is negative 4 because if I let x be 0, I would have negative y equals 4, which is going to mean that y is negative 4. I can find my x-intercept by saying, okay, my x-intercept is the value of x when y is 0, so I have 2x equals 4, and that would mean that x equals 2. So you could just do it by intercept. That's your call, okay? So let's see. If you do it by slope-intercept, 1, 2, 3, 4, negative 4, slope rise 2, run right 1. I'm putting a lot of dots just so I know I can get a straight line when I do this. Okay. And I'm going to connect. I'm going to turn that back to my pen. And we put arrows. And since we are graphing 2 lines on this, we need to make sure that this is labeled 2x minus y equals 4. Okay. Now I'm going to change colors. And now let's look at the line 2x plus 3y equals 12. And again, you can do this by slope-intercept, or you can do this with the intercept-intercept. So if I'm looking for my x-intercept, that's the value of x when y is 0, so that y term goes away, and I have 2x equals 12. That means that x is 6, so my x-intercept is 6. My y-intercept is the value of y when x is 0. So the first term goes away, and I have 3y equals 12, which means that y is 4. If you did it the other way, okay, you subtract the 2x from both sides, and then you divide every single part by 3. So y equals negative 2/3 x plus 4. Now you can see your slope is negative 2/3, and your y-intercept is 4. So you would start at 4. 1, 2, 3, 4. Go down to right 3. Or we're using our x-intercept, 1, 2, 3, 4, 5, 6. Either way you do this, your call. Okay, I'm going to turn off my line. Whoops, sorry. Turn off my line. And put my equation. 2x plus 3y equals 12. Now I look where they intersect. They intersect right here. So my solution is going to be that point, which is the point 1, 2, 3 for x, and then up 2 for y. So the x value is 3 and the y value is 2. And there we go, guys. We have solved systems of equations 3 ways. Graphically, by elimination, and by substitution. Okay, guys, have a good day. Bye.